get set up here in Discord. We should be good to go. Good morning, everybody. Welcome to another week of, well, not sun, but math. So that makes up for it. Before we begin, as always, can someone just let me know in chat that you can both see and hear me, so my paranoia is calmed a little bit.
Sounds great. Happy Monday.
Happy Monday. Well, I hope so. Now, just that's fine. Okay, perfect. Okay. Now, we had our discussion on logical statements, negation, a little bit broken up by the weekend, which could be a good or a bad thing. But regardless, sometimes it's good to let things just sit in the back of your mind, and it gets better when you look at it a couple of days later. Sometimes it clicks, sometimes it feels better. Who knows? Okay. I see some people in Discord have the deafened selected as well, which means you can't even hear me. So I'm not sure what's happening there. I'm just going to move on. Okay, so we did last time uh, look at a couple of statements. And a statement, remember, is a sentence that is either true or false, nothing vague or having a double meaning or self contradicting or any nonsense like that. And then, as an exercise to just become aware of critically thinking what statements mean, we practice the concept of the negation, which is the opposite statement. When the given statement is false, the negation has to be true. When the given statement is true, the negation has to be false, the exact opposite. Now, we can take a slightly different spin on this, which essentially still is the same thing, but for some reason I find it a little bit more intuitive, even though it is still a negation question. And that is exercise 2.3, where we're given some statements, and I want to see it as explain how I would disprove the following statement. So someone rushes in and makes a wild claim, all dogs are fluffy. What would I have to do to disprove their statement? Their statement might be true or not, but if I want to disprove it, I'm going to have to do something. What would that be? Now, notice that this is pretty much the same as the negation question, because in order to disprove them, the opposite has to be true, and that's exactly what the negation concept is. So let's start writing stuff down. So nothing is going to change. Maybe my phrasing of the answer, but that's about it. No, 2.3. All right. So number one, their statement is all dogs are fluffy. So I can now again look at, that was supposed to be a B, being fluffy. And that would range from none to all. Now, some might feel that this drawing is a little unnecessary or silly, but I've seen many, many times people struggle with phrasing the negation effectively, and then when we discuss it, I realize they didn't have any visualization to help them. So it makes a huge difference. So given statement, we'll do it in black. All dogs are fluffy. So that is only going to be true right there. So given statement is true for that black dot. So I have a bunch of situations where the given statement would not be true. We'll stick with pink. So anything as soon as I step away from all, including none, would negate the given statement. So we'll do it in two ways. I'll phrase the negation as then, there's multiple ways of doing this, of course. It's very similar to what we did last time. A favorite way for me is to say at least one dog is not fluffy. Now that's the negation phrasing. The answer for the exercise 2.3 version could just be show or find. Well, let's do the show version. Show that at least one dog is not fluffy. And you see it's exactly the same thing, to the point where if you phrase the negation instead of the slightly different variation, I'm still going to accept it. It's the same question, really. So we don't want to get caught up in the exact phrasing. The essence of the negation is still there. But sometimes if I imagine someone making a statement and I want to disprove them, what would I have to do? It gives the negation concept maybe a little bit more of a setting, and maybe that feels a little bit more intuitive for me. Maybe not for you. It's the same question. Whoopsie. All right. How do we feel about negation this morning? Oh, it depends on where you are, I guess. To be not morning anymore. Hmm.
Pretty good.
All right. And it just takes a little bit of practice, see some variety, and you see there isn't that much in terms of variety. All right, number two. Some people do not like to eat turnips. Now, once I realized the benefit that this visualization gives me, I'm not even gonna, and it's so quick, I'm not even gonna bother not doing it and running the risk of phrasing my answer in a slightly incorrect way. So I've gotten into the habit of, regardless of how simple or easy the exact statement may be, I'm just always going to go through the same movements, getting to the answer. Oh, I see we got. No, I see. Okay. Uh, so I don't really look at it. It's about. Oh, I don't look at it in its entirety. The second statement is about people not liking turnips. Okay. So not liking turnips. And that is, of course, going to range from none to all. So it doesn't actually matter what the topic is. Now I look, okay, well, in this situation or the topic, some people have this property. Now I know that for our purposes, some means at least one. That means maybe over here, that could happen and the given statement is true. Maybe over here, maybe over here, maybe over here, maybe over here. A lot of different situations where the given statement can be true because some, at least one, means one or more. And we've also discussed last time that includes the all situation. Given statement, true. If all people have this property, then some certainly do. Just check the chat here. Can everyone make sure they're on mute, please? I'm hearing lots of background noise. Really? I hear nothing. And someone has spoken, so I do hear my audio is set up. I'm not sure. I hear nothing and everyone is muted. That's weird. I'm not sure why you would hear background noise. Does anyone want to say something just so I can check my audio?
Hello.
Yeah,
Hello.
okay, no. I see everyone's muted. I'm not sure why you're hearing
Hi.
background noise. Yeah, that's weird. Maybe it's actual background noise. Oh, anyway, problem solved. So we have a slightly different looking uh, situation, and but once I visualize it, now I see, oh well, the negation uh, has only a little part to cover, which is over here. So I can then phrase it one of two ways. I'll go with the way this question ideally wants, that I have to show somehow, it doesn't have to be practically possible, show that, now I'm just going to stick with this, which means no people, right, because I'm right in line with none, have this property. And the property in this case is not liking turnips. So no people, let's say here, don't like turnips. Now, depending on how things were given and where my pink dot is, the phrasing of this sentence might not be ideal. I can totally leave it like that. We're not doing a language class. So I don't care about the grammar or what your sentence sounds like as long as it's technically correct. But of course, this might not feel ideal. So I can then update it and clean it up a little bit. I still wouldn't skip this first step. And if it doesn't sound good, I can then clean it up. That if no people don't like turnips, how can I clean this up? What would be the better sounding version? No one doesn't like turnips. That would mean
Everyone.
everyone. But it could be confusing if I don't have this bad sounding version on the way to maybe a linguistically better way of saying it. Technically, the information is still correct. Of course, I still need here the show word I forgot. So I wouldn't want I want some consistency, right? I want to see my line. I want to see the property. Where is the pink dot? Phrase it according to those things. And then if that sounds weird, clean it up afterwards. Then I have that consistency and repetition in how I approach these things. But if it's a combination of like this has a negative in it and I'm at the none spot, then I have this double negative idea and it could sound a little strange when I look at my first attempt. Cleaning it up afterwards is not a big deal. But jumping directly to that last version might sound a little, might seem a little confusing. Okay. Number three, everyone plays better tennis than Fred. So we're playing better tennis. Could range from none to all. And in this case, everyone plays better. So I'm sitting over here again. And you see some repetition inevitably occurring because we don't have that much variety. I can then say, well, my negation is true as soon as I step away from that, all the way to the end. So I would just have to show or find, let's say, show there is at least one person that allows me to step away from this all? Who does not play better tennis than Fred? All right, hopefully, slowly, whoops, things are starting to feel a little better. Once you see some more examples, it should start to show that it's not as bad as it might initially have felt. But we do have time, so it's okay if these things take time. Number four, last one. Nobody plays mini golf. So this is playing mini golf, ranging from no one to everyone, or whatever words you want to use there. I don't understand that YouTube comment, so I'm gonna move on. Oh, show, haha. Like, do I put on a show? I am a polar bear, but the show here simply means, now I understand your question. It simply accommodates the slight variation in the question. Like, if I'm trying to disprove a statement and make the negation true, I'm going to have to sort of do something. And somehow I'm going to have to show that there are people that don't play better tennis than Fred. But you can totally just phrase the negation uh, in the previous style. It's just a different style, different spin on the negation as well. So if you just want to do the negation and say there is at least one person who plays better than tennis than Fred, that's totally fine as well. It is the same concept. I just want to put a little bit more of a practical spin on it, maybe, and it feels more intuitive for me. But it's totally just some variety to make you feel better, perhaps. So this one says nobody plays mini golf. So I'm gonna sit right here, right there. Ooh, we can fit it in. Okay, so that means that my negation is gonna be everything else, including all. And we've seen these things before. Now I'm just sticking to the style of this question where I want to show the negation is true. What would I have to show? I have to show there is at least one person, whoopsie, what was the situation? Oh, that plays mini golf. One person who plays, my writing is not very good today, mini golf. And of course, the negation would be there is at least one person who plays mini golf. If I want to prove that the negation is true, which is the opposite of this of the given statement, I'd have to show what the negation wants to show. Right. All right. So that was a fair number of examples. Hopefully, it feels better. And if it doesn't, you can now use the problems 2.1 and 2.2 as extra practice. Uh, and if you have any questions, we had a Q&A session on Thursday. No, Friday. No, what was it? Thursday. Man, I'm terrible. Pretty sure it was Friday. And we had a Sunday morning one. Uh, so there, look at the schedule, and there are Q&A sessions that you can use to answer your questions. All right, so now when we we're now a little bit more aware and thinking a little bit more critically about what we're reading, statements, or maybe statements we are making. We're getting used to that. So let's now string a few statements together and see what exercise 2.4 has for us. Again, trying to contain the situation, trying to make it as simple as possible, not let things get out of hand. Oh, I see a chat question. Oh, I thought I said it. So a chat question. I swear I saw one. No, I guess I did not. Okay, so determine hmm, determine whether the following arguments are valid, meaning logically sound. So let's just read the first one, and then we're gonna talk about how we approach it. It's an argument. It might be a sound argument. It might not be. I have to figure out if it is, which one it is. All college students are brilliant. All brilliant people are scientists. Therefore, all college students are scientists. Now, some people have a fairly good intuition based on their experience or whatever, and they can just read something like that and know, yep, logically sound, sounds good, or no, that's not right. It's not just about knowing the answer for us. It's about, can I explain why I say that? Can I explain it to someone else and teach someone else that might be confused and don't know what to make of this? Can I clarify it? So it's not just about finding the answer, it's can I explain that answer and in the process verify that I'm correct as well. So how we're going to do this is we're trying to figure out if the conclusion that they're making follows with certainty from the first two statements. So that means regardless of the truth practically of the statements that they're making, I'm trying to evaluate their argument. So I'll assume that all college students are brilliant. I'll assume that it's true all brilliant people are scientists. Based on those two statements, does it follow with 100% certainty the conclusion that they're making? So now there are different groups of people involved here. There are college students, there are brilliant people, and there are scientists. And to make things manageable, we'll always have three groups that overlap in some way. So what would help me is to first make a new page and to visualize the situation better. Okay, so let me just number this. I'm still pink. So this is exercise 2.4, number one. Let's see here. So I want to have all the people on the page here. People are on this page somewhere. If I want to visualize the college students, I'm going to do that by way of a circle. And there is my circle. Inside are all college students. Outside are other people. So I have my circle of college students. Now I'm going to have a circle of brilliant people as well. The question is, where should the circle of brilliant people be so that this statement is true? All college students are brilliant. Can I put the circle over here? And that's going to
No.
be brilliant people. No, because the statement says all college students have to necessarily be brilliant. Well, there's a college student right there, and they're not in the brilliant people circle. Okay, so let's back it up. And again, I'm taking my time with this first one. It'll get faster as we go. Can I do this?
No.
Why not? I want to. I did it. Why not?
I was thinking the brilliant people would be bigger than the college students.
Yeah, if I definitely they can't be detached. But if I do it this way, then there could be a college student that's not necessarily brilliant, right? So I'm going to have to do it the other way around. Back it up. There we go. Maybe like this. Brilliant people. Now, anyone that's a college student is inside the college student circle, which is necessarily inside the brilliant people circle. So now all college students are definitely brilliant people. There could be a brilliant person that's not a college student. The statement does not say anything about that. It only goes one way. If you're a college student, then you have to be brilliant. It doesn't go the other way. Okay. Is everyone happy? So I have to leave space here for the potential of brilliant people that are not college students. Any questions on this layout? I want to visualize what information those first two statements are giving me, so that it can help me figure out if the conclusion is 100% certain or maybe just likely. Because if it's just likely, then it's not logically sound. It has to be a certainty, which means I need to really understand the first two statements. Okay. But now there's another one. So I've checked the first statement with this situation is definitely going to be true. Now I want to make sure that the second statement is true as well. All brilliant people are scientists. So now I have the brilliant people circle. So there's a bigger one. All brilliant people have to also be scientists. So definitely I can't draw the scientist circle over here somewhere, right? I need brilliant people to automatically be scientists. So should the scientist circle be inside or outside brilliant people?
Outside.
Outside. Let me draw it. Maybe like that. Maybe here, scientists. Has to be outside because as soon as I take a brilliant person, which is in the brilliant people circle, they have to always fall in the scientist circle as well. So scientists couldn't be inside. Then I don't have a guarantee that this statement is true. Again, this doesn't say anything about a scientist that's not brilliant. That could totally happen. It only goes one direction. So I'm laying the foundation. Whether it's practically true or not, it's irrelevant. I'm evaluating the argument. I'm evaluating the conclusion, really. So I assume the first two statements are correct and true. Then this has to be the situation. Now I evaluate, is this conclusion necessarily true based on this? And the conclusion says, therefore, all college students are scientists. Well, any college student is necessarily in the scientist circle, so all college students are scientists. It's impossible, based on this, it's impossible to find a college student outside the scientist circle. It's impossible. So my conclusion is it is logically sound. I'm not going to write a lot because my diagram is my explanation. Of course, it helps. If I'm actually explaining it to someone, I have to be there to do it. But in terms of a test question, my diagram is my work that I show. All right. So that's going to be our strategy, and we're trying to sort of have that same strategy repeat so things aren't too overwhelming. Any thoughts or questions on this one? Because once I have my how I'm going to approach it, now it's just a matter of seeing some variety to get more used to it. Okay. So far so good. Let's see what the second one gives me. So now I understand that if I have this kind of question, I know my approach. It's just a matter of what the statements are saying, and that's going to, of course, affect my diagram, which then affects everything. Okay. So I want to identify what kind of people, what kind of groups am I working with here? Those will be my circles. And again, to keep things simple, we'll always have three. We're limiting the variety just to practice the concepts here. All poets are happy. So I'm going to have poets and I'm going to have happy people. I don't need to really worry about the rest right now. Those are going to be two of my groups. And I need to uh, have a layout that makes that statement true. All poets are happy. So I'm going to have a poet circle. Let's say maybe like that. Poets. Now, from my previous example, I've already gained some experience that I can now use here, being that if all poets are supposed to be happy, the circle of happy people need to be around the poet circle. Let's go big for no reason whatsoever. Oops, that was another P there. Happy people. Now I'm guaranteed that if you're a poet, you are necessarily inside the happy people group. But there could, of course, be others that aren't poets as well. Okay, so I'm very quickly actually getting used to this all statement. If all one group are also another group, then it's the first inside the second. It's the only way it can be. Okay. Now, the second statement is a different kind of statement. Some poets are lazy. Not necessarily all, just some. So my third group of people will be lazy people. And some poets are lazy. It's not the same kind of statement. This some statement requires that there's just an overlap between those two groups. Some of them need to be the same, not necessarily all of them. Some poets need to be lazy people as well. So now I have some options. I just have to overlap the lazy people with the poet circle. So it could look like this, and that could be lazy people. Then the second statement, some poets are lazy, will definitely be correct. There's a poet right there, and they're lazy as well. So a some statement requires an overlap. Everyone happy with the overlap? Does that make sense? Different kind of statement, it's a different kind of layout. Now it could have looked like this, but the second statement doesn't say anything about happy people. So I can't assume anything. The layout of lazy in regards to happy people could be anything as long as lazy overlaps with poets. So it could look like this, or it could look like this. I don't know, and I can't assume anything. There's still a poet that's also lazy. So I have to take into consideration all the possibilities, all the flexibility that I still have. And regardless of that flexibility, is the conclusion still 100% certain? The conclusion says, therefore, some lazy people are happy. Now, regardless where I put this lazy circle, it's always stuck with poets. It's always attached to poets by even a little, but still there, overlap. So it's impossible for me to draw the lazy people out here because lazy and poets need to overlap. And because poets are completely inside happy people, there is always going to be a lazy person that is happy. There could be some other people over here, but there's always going to be a lazy person that is going to be happy. And for that reason, some lazy people are happy is a logically sound conclusion or a valid argument. Because I want to. Ideally, I'd like to say that this is not a good argument. This is not a logically sound argument. But in order for me to do that, I'm going to have to get lazy and happy completely separated from each other. And I can't because I'm stuck with these first two statements. Is it still making sense?
Yes.
All right. Now we just see some more variety. So I ideally kind of want to have it not be logically sound. And it's only 100% correct the argument if I really can't get the wiggle room to get what I ideally want. I'm a little mean. I want this argument to not be correct. Let's look at number 3. Some poets are unsuccessful. So I have poets and I have unsuccessful people with a sum, which means an overlap between the two. So that could be my poets. And then I have unsuccessful people. Maybe like that. Unsuccessful. And because it's a sum statement, I just need an overlap. I just need there to be a poet that's also unsuccessful. Now I look at the next one. Some athletes are unsuccessful. Now that requires that the group of athletes and overlap with the group of unsuccessful people. And it doesn't say where athletes should sit with poets. There are many options. That's one, as long as athletes overlap with unsuccessful. But there's no uh, reason that I should assume that this is necessarily the case. It could look like this as well. So now I want to pick one. I pick a layout that is still correct according to the first two statements, but that shows that that third conclusion statement doesn't necessarily follow. So I do have to sort of read ahead before I commit to a layout. Therefore, some poets are athletes. So now I see that, okay, well, if I have this layout, poets and unsuccessful people overlap, so first statement is true. Unsuccessful people and athletes overlap, so the second statement is true. But there are no poets that overlap with athletes. So the conclusion that some poets are athletes may be likely, but it's not 100% certain. And for that reason, it's not a logically sound argument. Likely does not mean certain. And when I work with logic, it's all about certainty. All right, so there I found one that is not a valid argument, that they're sort of guessing or hoping. All right, hopefully it is quiet because it's so obvious and easy. And if that's not the case, then feel free to ask. Maybe today, maybe tomorrow, but definitely eventually ask if you have questions. Sometimes it's hard to know what to ask, and you need to think about it first, and that's totally fine. We definitely have the time. Let's see one more. One more? Yes, just one more. Number 4. All right. Where's my question? There we go. All geniuses are illogical. Okay, so geniuses and illogical people. And now it's an all statement, which means one is inside the other. Which one is inside which one? I have two options, right? I know an all statement. One circle is
Geniuses are
inside the
inside a
other.
logical?
First one inside second. Yes. So let's draw that. I've got the space. Why not? Genius. Oops. That looks good. And then illogical people. Whee. Let me just triple check. Yeah, it's fine. Just want to give myself enough space here. Illogical people. Okay, so now I've made sure that the first statement is correct. So it has to be that layout. Next sentence. Some politicians are illogical. Some. So the other circle is the politician circle. And only some politicians need to be illogical. It doesn't say anything about genius. So I have some options here. The politician circle could look like this, or it could look like this. I don't know. As long, the only requirement that I have to meet is that the politician circle overlap with the illogical circle. That second statement doesn't say anything about geniuses. So now I kind of have to scan ahead because I want this to be wrong. If I can find a layout that proves this wrong, then I kind of win. And if I'm really stuck, I cannot find one, then I'll give in and say, fine, it's logically sound. Can't find any hole here. So the third conclusion sentence says, therefore, some politicians are geniuses. Wow, that's definitely gonna not work because I can go with that first one, right? Oops. And say, well, if I have this, what was politicians, right? If I had this situation, first statement, all geniuses are illogical. Yep, good. Second statement, some politicians are illogical. Yep, they overlap, absolutely. But in no way is there uh, information or a guarantee that politicians have to overlap with geniuses. Yet the conclusion says some politicians are geniuses. So that is unfortunately not logically sound. It could be likely, could be possible, but it's not a guarantee. That is the thing. So for it to be logically sound, it needs to be that that conclusion is 100% certain to follow from the previous statements, and we only have two of them. So I kind of want this to fail. I kind of want to find a layout that doesn't work with that third statement. But I'm stuck by way of the first two. I'm sort of stuck. Within those requirements, can I still do it? And if they're stuck in such a way that I can't, yeah, in some cases, like this one up here somewhere, yeah, there was no way, right? Then I have to give in, say, okay, logically sound. This one too, there was no way to get that lazy people circle out because I was stuck to what I had to do. That logically sound, fine. But in some cases, however, I have some flexibility and show that there are situations, there is a layout where that third conclusion statement doesn't necessarily follow. Same for this one. So that's going to be my approach for this kind of question. And when you do see these in a test, perhaps, quite likely, you'll see similar wording, similar things. We're not suddenly going to have 10 sentences that you have to figure out. We do these because they are indicating the level of difficulty we're aiming for. So they'll be familiar and you should know the approach that we ideally want to take. Then you can look at problem 2.3 and practice some of those. I think there is one that doesn't have an answer on the website, but that might not be a bad thing. Sometimes it's good to do something that you don't have the answer right away. Definitely when you do these, once you look, then it sort of ruins it. You can't unsee it. So ideally, don't look at those answers uh, ever. But if you really want to, make sure it's an absolute last resort. Uh, or we can discuss it first so that it doesn't ruin your learning because we don't have a lot of these examples. All right. Are there any questions about this section specifically in our last 5 minutes?
No, it all sounds good to me.
Usually there are questions. Maybe there are some people that are a little bit confused still, but it just takes time. Think about it. My best recommendation is when you do the problems, give them some time. If it's a struggle, give them some time. Think about them. Maybe walk around while you're thinking about them and doing something else. Maybe let them sit a little bit. Don't go and look at those answers really ever. Only for a confirmation. You're pretty sure you have it? Maybe then check it. I ideally don't want problem answers on the website, but then people complain as well. So I'm really sort of stuck in between. They're not a learning tool on their own. I would rather in a Q&A session discuss these if you aren't sure or you want me to check an answer or something. We have more than enough time. Yeah, the evidence is only from the first two. And then the issue is now we only contain it to two. Of course, it could be way more, making it more complicated. We'll stick to two. We have two statements. We're not evaluating the validity of those statements. We're evaluating the argument. So, assuming those first two statements are the case, does that third conclusion necessarily follow? So, those first two statements are sort of my restriction that tells me the layouts that I have available. Within that, is it 100% guaranteed that that third statement is also true? Sometimes it is, sometimes it isn't. And it's hard for me. I mean, I have no shame in admitting that uh, for some of these, if I read them quickly, I don't know with confidence if it's logically sound or not. Sometimes it sounds really good. But if you really go and evaluate it and seeing what the information is and what restrictions it gives you, then you see, oh no, it's not a 100% guarantee. It was just sounded very likely. So I really want a method, sort of a backup, that if I'm not sure or if I need to explain myself, I can write stuff down. I can draw a picture. I can figure it out because my feeling or my intuition isn't something I can really rely on when it comes to logic sometimes. So I want that backup, whether I just want to make sure myself that what I think is the answer is actually the case, or if I want to explain it to someone else. Because if I think about the teaching side of something like this, I might be very sure. Well, of course, it's logically sound. How do you not see it? But if someone else doesn't see it, I need something else to convince them. I can't be like, it's logically sound just because I say so. Just accept it. Why don't you see it? That's not how you teach, right? You need something else. Like, okay, let's sit down. Let's draw this out. Let's really look at it in more detail, and that will systematically convince them. So because we have sort of our foot in two areas, we want to be able to do it ourselves, yes, but everything we do, we also want to be aware of, okay, how would I explain this to someone else that doesn't quite get it the same way I do, that doesn't find this as easy? How can I lay out an answer? How can I structure my approach? Am I going to draw pictures? What am I going to do to help convince them? And in the process of doing that, I convince myself as well that what I'm doing is correct. So I never want to forget that side of it. Now, as we go to our puzzles, we have a variety of puzzles to now practice our arguments, our deductive reasoning. They are going to be a little bigger, some bigger than others, some small. The arguments are going to be, even in small cases, too big to write out in detail. And for that reason, we have to listen carefully when we say something because we're not going to write it out. We have to really think carefully about each step in our argument, how we're saying things, or if you're listening to it, each step, is that correct? Is that 100%? I never want to make any guesses, any leaps, any assumptions in deductive reasoning. But that is for tomorrow, I guess, another day. So if you have the time, look at the problems, review the video, do whatever you need to do, and we'll slowly inch our way forward through this chapter. Until tomorrow.